Hello guys, so this is going to be my first video on our lead code series that we have started, and let's start with our simple beginner level problem that is actually finding the duplicate inside of an array, like if the array is duplicate or not. So let's go through the problem statement. So we have this problem statement where we have an array and we want to find if this array does contain a duplicate or not. If it's there, then we return true, otherwise we return false, right? So let's go with the examples now and let's see how it goes. So we can see here we have an array and we can see here we have two duplicates, right? And now we need to find a methodology where we can actually find out how we can actually find it in the best time complexity. So first method that we have is our brute force method. And in the brute force method, what we're simply going to do is to iterate through the array until we find the duplicate. And we're going to iterate multiple times. So we're going to start from one, and then what we're going to do is to go till the end, and then we're going to start we already have found the duplicate in our first iteration, so we're going to return true. Let's go with the second example to understand it a bit better. So first we're going to iterate one time, 1 to 4. We don't find any duplicate, and then we're going to start from 2 to 4. We don't find any duplicate, and then we're going to start go from 3 to 4, and then we don't actually find any duplicate. So at the end of the day, we don't have any duplicate. So this means we're going to return false, right? Because this is a distinct array. So in the first methodology, what we have seen so far is that we are using two two for loops to iterate, and the time complexity for this is off and square because we are using two for loops and we are iterating multiple times. And for the space complexity, we're not altering anything, or we're not saving any data, any extra data. We are using the same array and iterating it. So we're going to say this has O1 complexity. And if we talk about the sorting mechanism now, in the sorting mechanism, what we're going to do is to simply first we need to sort this array. And we can use any method that is efficient in sorting mechanism. We can use bubble sort, any other method that we have to sort this array. And because of the sorting, we are going to have let's first define sorting. And then what we're going to do, we will have this resultant as 1, 2, and 3, right? We're going to have this as a resultant after the sorting. After the sorting is done, what we're going to do is to use some search method, like for example, um, binary search, for example. And using the search, we're going to find if this has duplicate or not, because we already have a sorted array, right? So if we use this binary search, we in our first iteration, we can actually find the duplicate here, right? So this means we can actually return true. So this is how things are going to go in the sorting mechanism. So if we break this down into time complexity, we have O n time complexity here, and we have O log of n time complexity here, right? And if we actually write this down here, if we combine those time complexities together, we will have O n log of n time complexity. Right? And we are not actually altering any memory here or not storing any extra memory. So we are going to like write O1 that is constant time complexity. We haven't used any space. So last but least, we have hash map here. In the hash map section, what we are going to do is to use our hash maps to see what elements we have traversed so far. So what we're going to do is to simply go through this array only one time and store those iterated array. For example, I'm going to use our set here. For example, we have first element is 1. We don't have any 1 in our hash map, so we're going to store it. Then we have 2. We don't have any 2 in our hash map. We're going to store it. 3. And then we actually find again 1. So we already have that. So we're going to return true here. So this is going to be our result here. That is actually going to be true, right? So we're going to write true as a return. So if we go through this, we have one, two, three, four. All of those are distinct, and the so we have our loop is complete. So we're going to just return false. So in this, we have the best time complexity, that is O of n, but the space complexity is going to be O of n as well, because obviously we are storing the elements as well, and can be maximum. It can be all of the elements if it is a distinct list. So this is going to be it. So if you like the video, do remember to subscribe and like the video, and also put your suggestion in the comment section as well. I would definitely be looking forward to those. And have a great day. Take care, guys. Bye.